Today, my lovely fans, I received some of your critics' comment about the clarity of my last videos, and I certainly want to tender my apology. This particular video here, I'm promising you that it's going to be fine, very clear as than before. Okay, today's class is going to be based on theoretical probability. Now, what is theoretical probability? This simply means that a probability that is being calculated without any experiment being performed. That is, we only guess or we only bring out the physicalization of that question to be able to solve the problem. That is from the word theory. Okay, let's take an example. Example one says that a fair coin, a fair coin is tossed 3 times. Okay, what is the probability that two head and one tail will appear? Okay, now solution. For a coin, we all know that a coin has two sides, either head or tail. Okay, now if a coin is tossed 3 times, we need to get a total event here. Now the total event here is just simply using what we call power set in set. Flashback to set, although my video is going to be released on set very soon. Okay, total event is on power set, and power set is simply equals to 2 raised to power n, where n is equal to the number of times the die is being thrown. So that's going to be 2 raised to power 3, and that is what, 8. So these are total event. Okay, now to get the event of a coin, now we need to get the total number of what possible outcomes, which is same as total event, which is same as event. So we say number of possible outcome or simply event can be, okay, when you toss coin 3 times, you have possible size. Okay, let's list out the possible size you can have the head. Okay, we have the head tail. Okay, we have the head tail head, we have the tail head. We can also have the tail head. We have the tail head tail. We have the HTT. Okay, possible outcome. And lastly, we can have the tail showing. So you can see the number of outcomes you have there. They are the same thing. They are equals to the equals to this word, to this 8. Okay, that's total event 8. Now, but the question says, what is probability that 2 head and 1 tail will appear? Now let's figure out 2 head and 1 tail. This is 2 head and a tail. Another 2 head and a tail. So okay, which other one? We have 2 head and a tail. That's 3. So we can simply say our event in this case is simply what, 3. So we can now say probability of having 2 head and 1 tail is now going to be equals to the event over total event. Now what's the event? The event is simply 3, and the total event is simply what, 8. And that's all. Okay, now let's go to example 2. Now example 2 says that, okay, let's take a question. Okay, two number are selected at random from 1, 3, 6. Okay, find the probability that the number is a multiple of 9. That is the question. Okay, solution. Now, given question like this, where you have digit like this, and they say find the sum of the number Sorry, this is not correct. Sorry for that. Find probability that sorry find probability that the sum, let's use the sum of the two, yes, okay, number is not odd. And this is the question. Okay, this is arranged now. That other one is not correct because there is no way I want to put nice. So I please change the question. Find probability that the sum of the two number is not odd. Okay, solution to this. Now, when you're given digits like this, you have to just simply arrange them. Now, how do we arrange them? You arrange these digits in both the vertical axis and the horizontal axis. That is 1, 3, 6, 1, 3, 6. You can see arrange in vertical and horizontal. So how do we fill in this? We simply add this with this. 1 plus 1 is 2. 1 plus 3 is 4. 1 plus 6 is what? 7. 3 plus 1 is 3. 3 plus 3 is 6. 3 plus 6 is 9. 6 plus 1 is 7. 6 plus 3 is 9. 6 plus 6 is what? 12. Okay? Now, the sum of the two number is not odd. Okay? That means if the number is not odd, that means it can either be prime or even number. Okay? But in this case now, the odd, let's figure out the odd first. These are the odd numbers, which are 4 digits. So we say 4 event here is equals to what? 4. This, and this. Okay? Don't forget that odd numbers simply means numbers that can actually be divided by any other numbers and 1 except 2. Okay? So event is equals to 4. Then total event, let's figure out that. It's just simply when you take this digit 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our total event. Okay? So but because you don't say not odd, go back to the equation of probability that I said under general formula. We said probability of success plus probability of failure, they must be equals to 1. So that means in this case, we are considering not odd as failure. So you can simply say probability of failure must be equals to 1 minus probability of what? Success. That's when you collect like that. So we can do the same thing here. We just simply say probability of not odd is equals to 1 minus event over total event. Then we look for the LCM. The LCM here is simply 9, right? 9 divided by 1 is 9. 9 times 1 is what? 9. 9 divided by 9 is 1. 1 times 4 is what? 4. So this simply gives us 5 over 9. Now, instead of going through this stress, you can still solve this question like this. Okay? Since the set is not odd, that means it can either be a prime, like I said before, or even number. Now, look at the remaining figures we have. We have, okay, sorry, this is 4. Sorry for that, this is 4. So we have this. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the event here is what? 5. Of either prime or even. It's going to be 5, which is the left value, over the total event, which is what? 9. So you can still solve it like this, or you solve it this way. Okay? That's example 2. Then example 3. Let's take another example. Example 3 says that a number is selected at random from 41 to 56. What is the probability that the selected number is a multiple of 9? Now, solution. To get the total event here, we simply say total event is equals to, now we can simply arrange this value, like figure it out, but it's a waste of time. Let's just 41, 42, 43, 44, 45, 46, Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So our total event here is 16. But instead of doing this, why can't just use a simple way of solving it? This is what you do for us to get this 16. Okay, just simply take the last value here, which is 56, minus the first one here, which is 41, then plus 1. So this minus this gives you 15 plus 1. That's what? 16. So you have the same value as this. Okay, now that's our total event. Now the event now is simply multiple of 9. So what are the values that can go in 9? We have the 45 and we have the what? 54. So that's simply what? 2. That's our event. So we now say probability of multiple of 9 is now going to be 2 over 16, and that is 2 here 1, 2 here 8, and the answer is 1 over 8. Okay guys, this will mark the end of today's class, and I want you guys to please, as I said before, this is going to be more clearer than before. Kindly like, share, subscribe, and leave a comment in the comment section. I will see you guys in my next class. I really appreciate you guys. Thank you very much and have a lovely day. Bye bye.